Welcome to our quick dive into the world of bits and binary systems. You know, those ones and zeros we always hear about. They might seem kind of basic, but trust me, they're the backbone of everything our devices do. Today, we'll break down what a bit is and why the binary system is so crucial for computers. We're talking the language computers actually understand, and it's way simpler than you might think. So, whether you're a tech enthusiast or just curious about how your devices work on a deeper level, stick around because we're about to unravel the mystery of bits and binary. Alright, let's start with the star of the show, the bit. Think of a bit like a coin, right? It's got two sides, heads or tails. In the digital world, those sides are represented by a 1 or a 0. That's it. Just two options, on or off, yes or no. Now you might be thinking, two options, that's it? How can you build anything complex with just that? And that's the beauty of it. Just like we combine letters to form words and sentences, computers string together tons of these bits to represent information. Every image you see on your screen, every song you stream, every line of code in your favorite app, it all boils down to these simple ones and zeros. It's like a secret code that your device knows how to read. Pretty mind-blowing, right? But we're just getting started. Let's see how these bits actually exist inside your devices. So we've got these ones and zeros, but how do they physically exist inside our devices? Well, imagine a tiny switch, even smaller than the ones on your keyboard. That's essentially what a transistor is. These transistors are like the building blocks of computers. They can be switched on or off, representing a 1 or a 0. And when I say tiny, I mean really tiny. We're talking billions of these transistors packed onto a chip the size of your fingernail. And here's where it gets really interesting. These transistors use electrical signals to switch between those ones and zeros. Think of it like a flow of electrons, kind of like a current in a river. When the current flows through, the transistor's on, representing a 1. When the current's blocked, it's off, representing a 0. It's like a super fast Morse code happening inside your devices millions of times per second. Chapter 3. Why binary system for computers? Now, you might be wondering, why binary? Why not just use our regular decimal system with 10 digits? Well, it all comes down to efficiency and reliability. Computers are electric, right? And electricity likes to be simple. With binary, it's all about whether a signal is present or absent, on or off. There's no in-between, no room for misinterpretation. This makes the system incredibly robust, especially when you're dealing with millions of calculations per second. Imagine trying to represent 10 different voltage levels for each digit in the decimal system. It'd be a recipe for disaster. One tiny fluctuation in power, and your computer could misinterpret a 3 for a 7, and things would get messy real quick. Binary keeps things clean, efficient, and reliable. It's the foundation that allows our computers to perform complex calculations with incredible speed and accuracy. Chapter 4. Simplicity. One of the biggest wins for binary is its sheer simplicity. With only two digits to worry about, 0 and 1, the rules for arithmetic become incredibly straightforward. Addition, multiplication, way less complicated than what we're used to with 10 digits. This simplicity translates directly to the hardware. Remember those transistors we talked about? Designing circuits that can handle just 2 states is way easier than dealing with 10. It's like the difference between building a light switch and building a 10-way rotary dial. This simplicity in design also means fewer components, less complexity, and ultimately lower costs. It's a win-win all around. Chapter 5. Reliability, but simplicity isn't the only advantage of binary. It's also inherently more reliable. Remember those electrical signals? Well, they're not always perfect. There can be noise, interference, and voltage fluctuations that can mess things up with a 10-digit system. Even a small error in voltage could lead to a wrong interpretation. But with binary, those signals just need to be above or below a certain threshold. It's like having a clear dividing line. You're either on one side or the other, with no ambiguity. This makes the system much more resistant to errors. And in a world where computers are handling trillions of operations per second, that reliability is absolutely crucial. And that's a quick look at why bits and the binary system are so fundamental to computing. They're the unseen heroes powering everything from your smartphone to the most powerful supercomputers. It's pretty amazing how something so simple can be the foundation for such incredible complexity. So next time you're browsing the web or playing a game, take a moment to appreciate the billions of bits flipping on and off behind the scenes, making it all possible. Thanks for watching. Don't forget to like, share, and subscribe for more tech insights.